David Smith here with one more flipped classroom math lesson. 3 tips. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause a video at any point to catch up with your notes or jot down some questions. Third, you can turn on the captions and read my words on the screen. Today's topic is about this thing called the discriminant, and it's a kind of quick little check tool that you can use to determine how many solutions your quadratic function has. But before we do that, I want to do a quick spot of review here. I've got 3 problems for you. I'd like you to solve these 3, and I gave you a little prompt. Do this one with the quadratic formula, do this one by factoring, and do this one by completing the square. So go ahead, pause the video, work those 3 problems. This practice will be good for you. Okay, let's see how you did. I worked all of those for you, and if you worked them and did them correctly, you probably noticed something that was going on. We had a different solution set for each one. This one gave us 2 solutions, this one gave us 1, and this one gave us no solutions. So we're going to come back to that in a minute. First off, take a look at the quadratic formula. Here's our formula. I did my plug-in step here. You want to check your work, make sure you got the right steps. That's a pure plug-in. Then I crunched my numbers down. In this step, I reduced my root 76 to 2 root 19. That's because 76 is 4 times 19. And then I could reduce down by canceling to get minus 3 plus or minus root 19 over minus 5. And then minus 3 and minus 5, that's going to be 3 and 5. The 2 negatives cancel each other out. And yeah, then it's going to change signs on the plus minus, but guess what? We got both of them, so we still have both of them. So this one is 2 solutions. We have 3 plus root 19 over 5 and 3 minus root 19 over 5. Moving right along. Our factoring one was pretty straightforward. Best for factoring, actually for most of these, get rid of the negative in front of the squared term, in front of the quadratic term. So I just multiplied through by -1. Then I noticed I had a perfect square, which I factored down to x plus 3 squared equals 0. Finish that out, I get x equals minus 3. 1 solution. Finally, on this last one, by completing the square, what I did was I first divided through by -2 on both sides of my equation, and then I took my b over 2 squared, and that was 1. I had moved my 5 halves over to get -5 halves. Here's my 1. So this side of the equation is minus 3 over 2. Then I can factor this down because it is a perfect square, and then take the square root of both sides, and I end up with a negative number under the root sign. So that means no solutions. So again, here we go. We have 2 solutions, 1 solution, and no solution. In fact, every quadratic is going to have one of these outcomes. So we're going to learn about the discriminant next. The discriminant is just that piece of the quadratic formula that's under the square root sign. So that is b squared minus 4ac. That's the discriminant. And we use the Greek letter delta to symbolize the discriminant. And we have 3 states that are interesting to us. First off, if the discriminant is bigger than 0, if the discriminant equals 0, or if the discriminant is less than 0. So pause the video and think about what you might be able to say about the solutions to a quadratic function in these 3 cases. Okay, the key to figuring this out is about looking at what's happening under the square root. So if you have a positive number under there, you're going to have a plus or minus the square root of that positive number. So that's where your solutions are going to branch. You're going to have one thing where you add the square root to whatever else is going on, and you'll have another solution where you subtract that same square root from whatever else is going on. So when the discriminant, when b squared minus 4ac under the root sign is positive, which is bigger than 0, you're always going to have 2 solutions to your quadratic function. Secondly, when b squared minus 4ac equals 0, that means you have 0 under the root sign, so that just goes away. Plus or minus 0 has no effect on the outcome of the solution. So all you have left in your quadratic function is your b squared over 2a. And that's going to give you 1 solution. So that's what we have here. And then finally, if the discriminant is negative, if it's less than 0, we have no solutions. We can't take a negative square root, so we stop right there and we say no solutions. Now let's talk about what that means for the graph of a parabola. Actually, I want you to stop the video and make a really quick sketch to show a parabola that satisfies each of these three states for the discriminant. All right, let's zip over here and take a look. There are just two parabolas here that meet the criteria for having two solutions. You'll remember, solutions are the x-intercepts, because where it crosses the x-axis, y is equal to 0. And that's what we're doing here with our equations. We're solving it for y equals 0. So there's two possibilities for two solutions. Here's two possibilities for one solution. It just touches the x-axis, but it turns right there. The turning point is at the x-axis, so we just have one solution. And then finally, here are two parabolas that have no solutions. And they just don't cross the x-axis. There's nothing wrong with those graphs, those quadratic functions. They just don't cross the x-axis. Let's do some problems evaluating the discriminant. Now, I've given you three quadratic functions. I've listed the discriminant right there. That's the b squared minus 4ac. And I've given you a prompt here. Use the discriminant to find the number of solutions. So we're not finding the solutions themselves. We're not using the entire quadratic formula. We're just using the discriminant. So go ahead and pause the video and evaluate the discriminant for each of these three functions and state the number of solutions. Let's see how you did. So check this one out. I just did my plug-in with the discriminant with that function. I reduce it down. I got negative 116. That means no solutions. Moving right along. This one, here's my plug-in step for that function. Work it on down, I get positive 33. That's kind of nice, and it tells me I have two solutions. Finally, this last one, when I plug in my A and my B and my C in my discriminant, work it on down, I get 0, which means we have one solution. So there's three different types of discriminant calculations. All right, here's an IB type question dealing with the discriminant. So we have this function, x squared plus 9x plus k. So we don't know what our constant is. So here's the question. Find k such that f of x has two roots, has one root, and has no roots. So there's a critical thinking step necessary to get started on this problem. Pause the video, think about this for a minute. If you figure that out, go ahead and find the value of k that satisfies these three conditions. The big step here is to realize that the discriminant has to be bigger than 0 for us to have two roots. So I can write this equation. B squared minus 4ac is bigger than 0. Now I can just do a plug-in step and put 9 is my b, so 9 squared is 81, minus 4 times a, which is 1, and c is our k. We don't know what that is, so I'm going to have minus 4k greater than 0. So go ahead and pause the video and solve that inequality. Let's see how you did. I just moved my 4k over. Remember, you can treat your inequality sign pretty much just like an equal sign. So I subtracted 4k from both sides, divided through by 4. I got k has to be less than 81 over 4 in order for us to have two roots or two solutions. Okay, so that's the condition for that one. What I want you to do is go ahead and pause the video and work the number for one root and for no roots. So here's how I crunch the numbers for one root. I realized that the discriminant has to equal 0. I did my plug-in, I moved my 4 over, I divided through by 4, and I get k equals 81 or fourths. So you can see on this one, I didn't do the math, all the steps. I just wrote k has to be greater than 81 over 4. Pause the video and see if you can figure out how I avoided all those steps. The crux here is to realize that 81 fourths is the borderline. When k is less than that, we have two solutions, and when k is greater than that, we have no solutions. And the trick to realize there is that the k is right here. The bigger we make this, the more it's going to subtract from our b squared, and the more likely that the discriminant will be negative, which gives us no roots. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.